So let's get into the other part of this study, which is deriving structures from name of organic compounds. Now, there are certain rules we have to follow. Let's look at them. The first rule is identify the number of carbon atoms in the parent name and write them out. So imagine I have a compound, for instance, 2-chloropentane. The parent name is this last part of the organic name, and pent simply indicates 5. Pent indicates 5 carbon atoms, so we'll write them out. So this is going to be 1, 2, 3, 4, and 5, and you're done. For the first rule, simply write out the number of carbon atoms in the parent name, and you have that as the first rule. We go to the next one. The second rule is allocate locants to those carbon atoms written out. And what are locants? Locants are simply serial numbers, 1, 2, 3, 4. So let's allocate locants. You could start here or anywhere, it's your choice. So I prefer to start from here, 1, 2, 3, 4, and 5. Very easy, right? Then we go to the third rule. The third rule is attach functional groups to the corresponding carbon atoms in the chain if present. Okay, so if we look at this, we might not necessarily see the major functional group here. What we have here is chlorine as a substituent, but imagine we had something like pent2-ol. Now, if you look at this particular compound now, you notice that the number of carbon atoms is pent 5. So let's put that down. 1, 2, 3, 4, 5. Second rule says allocate locants 1, 2, 3, 4, 5. Then we go to the third rule, attach the functional groups to the corresponding carbon atoms if present. In this case, we notice that the major functional group is here, and that is all. When you see all in a compound, it simply represents a homologous series known as the alkanols, which entails that there has to be the presence of the hydroxyl group. So this 2-ol implies that the hydroxyl group is going to be found in the second carbon atom. So we're going to attach our OH to this particular guy here, and that's that for the third rule. So imagine, for instance, we are considering an alkanone. Let's say we are considering the alkanone hexane 3-one. Hexane 3-one. What is this going to be? Hex means 6, so let's put that together. 1, 2, 3, 4, 5, 6. And then we have that the alkanone are represented by carbonyl groups. Carbonyl groups, specifically non-terminal carbonyl groups. Non-terminal is what is used to represent alkanones. Okay, so the carbonyl group is C double bond oxygen. Now, they said that the carbonyl group is going to exist on what? The third one. The third one. So let's count. If we allocate locants 1, 2, 3, 4, 5, 6, it simply means that the carbonyl group is going to be found here, and that's that basically about that. Okay, so with that said, we can go to the next rule, which is rule number 4. Rule number 4 simply states that we should attach multiple bonds if present to corresponding carbon atoms. Attach multiple bonds if present to corresponding carbon atoms. So we have, imagine for instance, they said we should write out the structure of but2-ene. So but2-ene, quite simple. First, but represents 4 carbon atoms, and when you see the suffix "ene", they're talking about an alkene which is characterized by the presence of double bond. So this 2 here is simply trying to tell us where the double bond is. So let's allocate the locants 1, 2, 3, 4. The multiple bond is placed between the number represented in the IUPAC name of the organic compound and a higher number, not a lower number. The number represented and a higher number. So it is now going to be existing between 2 and 3. So I'm going to place it here, not between 2 and 1, between the number given and a higher number. So have that in mind. So if I'm representing this is going to be but2-ene when you're looking at the structure generally. Okay, imagine I wanted to name something like let's say I want hept 3-ine, alkyne triple bond, and hept 7. So let's write that out. So that will be 1, 2, 3, 4, 5, 6, 7. Now that is the hept, meaning 7. So we have that is an alkyne, which means there's a triple bond and it is placed between the third and fourth carbon. Remember I told you that once you have a number represented here, the position of the multiple bond is between the represented number and a higher number. So this is going to be hept 3-ine. So let's get to that. This is allocating locants 1, 2, 3, 4, 5, 6, 7. 3 is here, so the triple bond is now going to be existing between this and this is hept 3-ine. Basic, right? Good. So we go to the next rule. The next rule is, after allocating the major functional groups and multiple bonds, you attach substituents to corresponding atoms. You know, every substituent is represented by a locant, you get, so you simply attach that particular substituent to the carbon bearing its locant. Now mind you, you have to attach the functional groups and the multiple groups first before you start attaching your substituents. Okay, so let's look at that. Imagine, for instance, I had a compound like, let's say, 2-chloropentane. So pentane 5, so 1 2 3 4 5. Then I allocate locant. This is number 1, this is number 2, this is number 3, this is number 4, and this is number 5. So 2-chloropentane simply means that I'm going to attach chlorine to what carbon? To the second carbon. I simply do this, and that's that. I've actually gotten the structure. Very simple, right? Okay, now let's take it up a notch. Imagine I had something like let's say I had something like 3-chloro penta 2-ol. So first of all is the pent represents 5. It's going to be 1 2 3 4 5. Next thing I need to do is to allocate the locants 3 4 5. And when I'm done with this, I first have to attach or find out the position of the functional group before I talk about the substituent. So the functional group in all is OH, and I have to attach it to the second carbon atom, so that's going to be here. And once I'm done with that, I can now talk about the substituent. Chlorine is the substituent, so it has to be attached to the third carbon atom, which is here, and this is 2-chloropenta 2-ol. Quite simple, right? Then we go to the final rule. What's the final rule? After you are done attaching the multiple bonds, the functional groups, and the substituents, you simply fill up the carbon atoms with hydrogen. Now, we have earlier stated that carbon can only form 4 different bonds. So when I'm filling it up, I just check what is the remaining number of bonds to this carbon atom and fill it up with hydrogen. So I have carbon, 1 bond is already here, so which means the remaining 3 bonds would be for hydrogen. Here I have 1 2 3 bonds, which means the remaining 1 bond will be for hydrogen. Here I have 1 2 3, so remaining 1, attach it to hydrogen. You have 1 2 here, the remaining 2 you attach it to hydrogen. You have 1 here, the remaining 3 will be attached to hydrogen. And that's that. You've gotten the structure completely for this particular compound. I hope this has been helpful. Now we're going to try one more question to end this video. So let's try deriving the structure of what we have on the screen. And what we have on the screen is 1-bromo 2,3 dichloro 5-methyl dec 2-enol. Now first of all is that the parent name has 10 carbon atoms. As you can see, dec means 10, so let's put the 10. We have 1 2 3 4 5 6 7 8 9 10. The next thing we need to do is to allocate locants. So let's start counting. We have 1 2 3 4 5 6 7 8 9 10. And after we are done allocating locants, first you attach the functional group to corresponding carbon atoms. So we have that whenever you have that there is no locant representing the functional group, it means that that functional group is going to be existing at the terminal point. Now first of all is we have alkanol here, and alkanol's locant was not represented, which means that it is going to be located terminally. So OH is going to be existing here. This particular 2 is for the ene, which indicates the presence of a double bond, alkene. So we have that OH, because there is no locant representing it, the implication is that it is going to be found at the terminal carbon atom. But in this case where you have 2-ene, it means that there is an alkene here. Enol, in all, means alkene and alcohol. So let's go on. So we go to the next one, which is attaching the multiple bonds. We have 2-ene. Where are we going to attach this? Between 2 and 3. Between 2 and 3. Remember, I told you attach it between the number given and a higher number, so that's going to be between 2 and 3. Now that we're done with attaching the functional group and the double bond or multiple bond indicated here, we can now go to the substituent. So let's start by attaching the substituent. We have the first substituent is bromo, located on number 1, so we have Br on number 1. Then we have 2,3-dichloro, which means chlorine is located on number 2 and is also located on number 3, just 2 of them basically. Then we go to the next one, 5-methyl. Methyl group is CH3. So you have that. Is there any other substituent? Since there is no other substituent, you can now fill with hydrogen. So we have 1 2 3 bonds, the remaining is 1. one hydrogen. We have 1 2 3 4. There's no longer space because carbon can only form bonds, so there's no more space for hydrogen here. Here too, 1 2 3 4, no more space for hydrogen here. Here we have 1 2, which means 2 more hydrogen atoms can enter, so you fill them up with hydrogen. You have 1 2 3, so the remaining is hydrogen. You have 1 2, hydrogen has to be here, hydrogen has to be here. You have 1 2, hydrogen will be here, also hydrogen will be here. You have 1 2, hydrogen is going to be here, and hydrogen is going to be here. You have 1 2, hydrogen is here, hydrogen is here. You have 1, which means the remaining 3 would be for hydrogen. I hope this video has actually been helpful. Remember, this is Wits Lounge, learning made easy.